Hi students, this is Neeraj Bansal and welcome back to my YouTube channel. Today we are going to do rules of differentiation as the continuation what we have done in the next video. See what I can advise you. I've seen many students who are watching the video like by making it forward and all. So what happens, you miss some important points. What I can advise you is see the whole video. Got it? Because whatever when I'm making a video of half an hour, that means that will be done in your class in 3-4 days at least. Got my point? So you need to see that video, take the time of 1 or 2 days after seeing the video and practice more questions. Then only you will be able to get the best of grades in IB, right? So let's start with today's topic, which is again rules of differentiation. Today we are going to talk about the inverse trigonometric functions, right? Inverse trigonometric functions, and then the higher derivatives, and then the implicit derivation. Got it? So first, let's talk about inverse trigonometric functions. The formula for these is given in the formula booklet. You don't have to do too much into that. I'll explain you what does this mean. You have to do three inverse trigonometric functions. Y is equal to arc sine x, y is equal to arc cos x, and y is equal to arc tan x. Is this clear? So for this, the formula is given in the formula booklet. Then okay, first I'll tell you the formula. So dy by dx for this sine x is 1 over under root of 1 minus x squared. And for second, that is cos x, it is dy by dx negative 1 under root of 1 minus x squared. And for arc tan x, dy by dx is equal to 1 over 1 plus x squared. Clear? Right, that is perfect. Now let's do some question on the basis of it. And obviously you have to use the chain rule, the multiplication rule, and the division rule to solve the question. So let's do some questions and you'll understand. So I'll take this and this question and we'll try to solve them. Let's take this, control C, and let's do. Perfect. So I'm having y is equal to arc 10x, 10 to x. Again, the best way is consider this as t. So this becomes arc tan t. So this becomes dy by dx is equal to dy by dt times dt by dx. Got it? Which will give me d of arc tan t over dt times d of 2x over dx. So arc tan t is 1 over 1 plus t squared times 2. So this will give me 2 over 1 plus t squared. So 2 over 1 plus what was my t? 2x. So 2x whole squared. Got it? Which means 2 over 1 plus 4x squared. This is my answer. Here, let's move to the next question. Y is equal to arc cos px, right? Again, I'll take arc cos p. So dy by dx is equal to dy by dt times dt by dx. Perfect. So that will give me, so differentiation of y is r cos t. So negative 1 under root of 1 minus t squared times differentiation of 3x, which is 3. So this will be negative 3 under root of 1 minus 3x whole square. Got it? Which will be minus 3 over under root of 1 minus 9 squared. These are the answers which I have got. Perfect. Now let's do this question. Let's So y is equal to x arc sine x. So u is equal to x and v is equal to arc sine. This means I have to use the product rule in this. Got it? So u derivative is equal to 1, v derivative is equal to 1 over under root of 1 minus squared. Then you need to put it into the formula. Y derivative is equal to u derivative v plus uv derivative. So u derivative is 1 times arc of sine x plus u, which is x, times v derivative, which is 1 over under root of 1 minus x squared. So this is arc sine x plus x over under root of 1 minus x. Right, so this is my answer. See, always remember one thing. Don't try to oversimplify. Yes, whatever you have got, if you leave it like that, that's fine. Unless stated that you need to prove in a certain manner. Got it? Then let's do this B part. Y is equal to e raised to the power x arc cos x, right? U is equal to ex and v is equal to arc of cos x. Then u derivative is equal to ex and v derivative is equal to negative 1 over under root of 1 minus x squared. So this will give me u derivative v plus uv derivative. This is u derivative. Was my u derivative? E raised to the power x times v, which is arc cos x plus ex, and v derivative is negative of 1 under root of 1 minus x squared. So this will give me what? E to the power x arc cos x minus e to the power x over under root of 1 minus x squared. Done. So I have done some questions in inverse trigonometric functions for you. Yes, obviously you have to do more practice. Got it? Now we'll come to another important topic, higher derivative. See, it's very simple. You have to keep derivating the things again and again. I'll just explain you what does this mean. Let's say if my y is equal to x cubed, right? So when I differentiate it, I'll get 3x squared. This is my first derivative. This is known as first derivative, which is written as v derivative, or I can write it as dy by dx. Then let's say I want to differentiate again. That means I have to find the derivative of derivative. So this becomes 6x. If I want to differentiate again, that means the third derivative, then it will become 6. Clear? So this is what I mean to what I mean to say when I'm saying higher derivative. Got this? Perfect. Next, we talk about implicit differentiation. Let's say if I ask you differentiate y squared, right? So normally you get differentiate y squared in the exam or in the questions. But actually, what does this mean? That means, let's say my s is equal to y squared, or t is equal to y, or whatever you want to say. Now, this is a very important term. In terms of, that means what is my independent variable? So if I have to do y in terms of x, what does this mean? This means the graph is something like this. If x is changing, my y is changing. Got it? So now I have to differentiate this function, basically, that means y squared, in terms of x. So ds by dx is equal to ds by dy times dy by dx, which will give me d of y squared over dy. Sorry, here you need to write times, not plus. Right? Times dy by dx. So this becomes 2y times dy by dx. So this is my answer for this. This is called implicit differentiation, right? So let's do some question. Copy. Let's solve it here. Right. So first we need to do y is equal to x. So I have to find, let's say my s is equal to 1 over y. I have to differentiate it. Got it? Or I can write s is equal to y raised to the power negative 1. So how will I differentiate? I'll differentiate in terms of x. So ds by dx is equal to ds by dy times dy by dx, which will give me d by dy of y raised to the power minus 1 times dy by, which will give me negative y, because negative 1 will come here. So minus 1 times dy by dx. So my final answer is negative y raised to the power minus 2 by dx. If you want, you can write it like this as well. Minus 1 over y squared dy by dx. It's up to you. Right? So you understand. In simple language, you will say, you whenever you have to differentiate y or terms in y, you have to add dy by dx in front. In very simple language. So let's say if my s is equal to xy squared, how will you differentiate? U is equal to x and v is equal to y squared. U derivative is equal to 1 and v derivative is equal to 2y. First you'll write like as it is, you are differentiating x. Then you have to add dy by dx. So my answer is y derivative is equal to u derivative v plus uv derivative. So u derivative v is 1 times y squared plus qb derivative 2xy times dy by dx. This is my answer. Clear? Now let's do x squared plus y cube is equal to 8. So I have x squared plus y squared is equal to 8. So what is the differentiation of x squared? The differentiation of, I have to find dy by dx from here. So x squared is, differentiation of x squared is 2x, and differentiation of y squared is 2y times dy by dx is equal to 8. So I need to make dy by dx as a subject. So 2y times dy by dx is equal to 8 minus 2x. So dy by dx is equal to 8 minus 2x by 2y, which will give me dy by dx is equal to 2 times 4 minus x by 2y. It has to be, so 2 cancels 2, so I'm left with 4 minus x over y. So my answer for dy by dx is equal to 4 minus x by. I hope this is clear whatever we have done today. Again, as I'm saying, lots of practice of different types of questions is required if you, right? So rest we'll do in the next lecture or next video. In the meantime, please subscribe my channel.